Hello everyone, welcome to the fourth lecture of first week of our course. Towards the end of the last lecture, we were already discussing about different platforms such as satellite, and even there different types of satellite platforms and also aircraft or drone based platforms, and how the sensors mounted on them they generally differ in characteristics. Now with this, let us take our discussion forward. We know most of us are aware of the visible spectrum, where we have the red, the green, and the blue color with their associated wavelength. However, in most Earth observation applications, mere RGB is not enough. You can consider a very simple example of burn soil versus bare soil. They may look very similar in RGB, but often other bands are helpful to distinguish them. The multispectral image typically contains the red, green, blue channel, additionally near infrared and other bands. Thus, the multispectral images, they are more informative than mere red, green, blue images. So you can think like this, the red, green, blue RGB image. If you, instead of this 3 channel, if you had just one channel, let's say only the green channel, so is not the RGB itself more informative than just green? So similarly, you are adding more number of channels and they contains more information. And what kind of information we will see soon. One thing that probably is good to clarify at this point is that sometimes in this course, even if we're talking about we're talking about RGB image, we will be using the word multispectral image. I mean, in a way, RGB is a type of multispectral, right? However, at this slide, when I'm talking multispectral compared to RGB, here we are making a clear distinction. So, let us now talk about some of the other bands that I just mentioned. So one is near infrared, and this particular band, and this near infrared itself, I mean, depending on the particular sensor, this itself can be divided into NIR 1, NIR 2, and likewise. So NIR, this is particularly useful for vegetation analysis. Similarly, we have short wave infrared. This is sensitive to moisture and is useful for drought studies. There are other applications as well. We'll come to that in the context of specific sensors. So now at this point also it's important to understand, let's say when we look at like the images, how we see is that like natural camera images we're talking about, like we see the RGB, right? So if instead of this RGB or this particular 3 channels, if we had, so think about this as like, like when you're visualizing in the computer, uh, if we had filled these 3 particular channels with some other channels, so let's say we had filled with the NIR, a combination of NIR and green, won't we be able to see something? We'll still see something. Okay, so you can play around doing this yourself, like read a multispectral image and there, like then make a particular 3 band combination with bands of your choice, and then try to just plot this. So what happens with these like particular bands is that in the multispectral image, that similar to like the camera images that we are more habituated to see, in the similar manner, this particular like multispectral image, the other bands are also generally visually distinguishable, though it may vary, like how much you can visually distinguish, that may vary on the specific band that we are talking about. On the other hand, it may also vary on the spatial resolution. So this is irrespective of the band, even if we are talking about the red, green, blue bands. If the spatial resolution is, let's say, very coarse, of course it's a bit like not so easy to understand visually what we are looking at. Another interesting aspect which probably needs mention is that, so we talked about this false color composition, right? So false color composition can also be created actually using images or bands from 2 different times as well. Like let's say you take a SWIR band, okay, which you just mentioned a while back, and then you make a like a kind of composition, like you take 2 different times, T1 and T2, and then you can make like these 3 channels. Channel 1, let's say this is SWIR T1, channel 2, let's say is the SWIR T2, channel 3 is, let's say, again SWIR T1, or it could be the other way around also. So this kind of false color composition with bitemporal images can also be created, and they kind of give us like, okay, what has been like happening over in the particular RY, like over the time, gives us a bit of like overview kind of idea. Of course, it's not a replacement for change detection, which we will be discussing later. So here we are seeing like one such false color composition of like bitemporal bands over a mountainous area where like also some burning incident has occurred. Here, so we talked about like, okay, we have this red, green, blue, or let's say we have an IR band, we have SWIR band. However, we are interested in like, let's say one particular aspect, like let's say we are interested in to understand the vegetation pressures. We are interested to understand water pressures, or we are just interested to understand the built up area. So in this kind of scenario, what's often done is that instead of like talking about this 5 band, 6 band, 7 band, we collapse this information into a single band or index. We call them spectral indices. Okay. Well, there are like many such spectral indices, like normalized difference vegetation index or water index or built up index. So we'll see. So we are looking at now NDVI, the vegetation index, and we see that this is a combination of near infrared and red, these 2 particular bands. This, as the name suggests, this is used for vegetation analysis. The vegetation generally will have higher value of NDVI. So you can like over a particular RY, you can actually put a threshold and you can say that, okay, maybe higher than this threshold corresponds to the vegetation, lower than this threshold doesn't correspond. Also, it's important to emphasize at this point, I mean, these indices, I mean, they are, like a overall, like they work like just like, as I said, that the bitemporal false color composition gives us a bit of like idea of like what kind of like change and what is happening over an area, but not really substitute for change detection, more sophisticated method. Similarly, this kind of indices also like give us a overview kind of idea, but of course it's not alternative for like more sophisticated deep learning or machine learning based analysis, which we'll be talking later in the course. Similarly, the water index, this is a combination of green and NIR, these two particular bands. And again, the water bodies typically have values on the higher end of NDWI. Similarly, another such index is built-up index, which shows built-up area and is a combination of SWIR and NIR, these two particular bands. Also, it's important at this point of time to mention that like in the last 3 slides, we have seen like in these 3 particular bands, right? These 3 particular spectral indices, and they are, I mean, like let's say for the water index, other kind of combinations are also possible. So if you're like, let's say, reading a particular literature where they show like a different version of the water index, don't get surprised, especially with like, it could always be the case we are referring to a particular sensor which has some more specialized like band, which has, let's say, like a multiple, like as I said, like the NIR or the SWIR, they can have like, they can be fragmented. So we can have NIR 1, NIR 2. So then you actually choose between them, like which one to be used. And the other aspect, which I also mentioned already, that the performance of such indices, they are like not at par with like if we talk about more sophisticated approaches such as deep learning based approaches. Also, such performance, what happens is that drops with the complexity of tasks. So like built up area, right? This is a bit more complex than rather talking about mere vegetation mapping. So most cases again depends on like, okay, what kind of complexity the vegetation is showing in that particular geography. But most cases what happens is that the built up area, this you cannot really like map so well with such indices. Whereas if your task is just vegetation mapping, such indices often work reasonably. Or if your task, let's say, is just water mapping, such indices work reasonably. So more complex task, we would probably more and more like go away from such simple indices. So at this point of time, also my suggestion would be that you can play around a bit with the indices, especially if you are not coming from your background, of course. If you are from Earth observation background, so these are like a kind of redundant information for you. Probably you would have played around a lot with such indices. However, as I would have expected, like maybe a significant part of the audience of this course is not actually from your background. So at this point, you can actually go to the Google Earth Engine code editor, and there you can load a Sentinel-2 image, and coding there is like quite simple. So there you can compute these indices that I have already mentioned, or any other index that interests you, and then you can visualize it. We get an idea like, okay, so you can visualize, like there is like a visualization panel available with the Google Earth Engine code editor itself. So there you can visualize, you can see the map, and you can toggle between different, like your index and the map. You can overlay also. So there way you can get an idea like how effective they are. Okay. So with this, some of the popular multispectral sensors are Sentinel-2, Landsat series like Landsat 7, Landsat 8. So we'll be talking a bit in more details about them. So also we have, so the Sentinel-2 or the Landsat 8, I mean, they are medium or coarse resolution, and at the same time they are free. That's a good thing. So Sentinel-2 is 10 meter per pixel, but that's free, and that's the reason. If you, I talked about previously, right, about conferences and journals. So if you, let's say, like pick up paper from like, so this is again not like a exact statistics. However, this would be my rough idea. Like if you pick up papers from the IGAS 2025, maybe at least 30 to 40% of the papers would have used Sentinel-2 in one form or other form. Whereas we have the high resolution ones, which are generally not free, like Worldview 2, Worldview 3, Pleiades, and so on. I mean, the commercial sectors, EO is rapidly increasing. More and more companies are entering this domain. And accordingly, more and more such high resolution sensors are currently available. Sentinel-2 is managed by European Space Agency. Sentinel-2, like we have like Sentinel-2A, which was launched in 2015, Sentinel-2B launched in 2017, 2C launched in 2024. The Sentinel-2, this follows a polar sun-synchronous orbit at an altitude of like 786 kilometer. At this point of time, probably it makes sense to talk a bit about. So we have already talked about like geostationary polar orbits. We have not mentioned about this sun-synchronous orbit, right? So sun-synchronous orbit is designed to ensure that a satellite passes over some part of the Earth at same local solar time, and this, in a way, I mean, of course, you will still have like other kind of variations. You will still have like seasonal variations and all. But what's important, I mean, is like for the analysis of the images is that like as far as possible to ensure like, okay, like the lighting conditions are similar, right? So this in some way, at least from the angle perspective, this tries to partially like achieve that, not completely, of course. So the Sentinel-2 covers 13 spectral bands with a swath width of 290 kilometers. These 13 spectral bands, they are divided into, they don't have like uniform spatial resolution. They are divided into 3 groups, spatial resolution wise. One group having 10 meter per pixel, which consists of 4 visible bands and one near infrared band. Then 6 bands which show 20 meter per pixel resolution, and then there are even 60 meter per pixel, that is much coarser resolution bands. So let us have a look a bit about these bands. So 10 meter bands, often called as band 2, is blue, one of them. So, like blue from our normal RGB. Similarly, band 3, green, and band 4, red. So these are 10 meter bands, but that's not all. We have one additional 10 meter band as well, that is band 8, near infrared, which has several uses such as vegetation monitoring, to some extent help with the water monitoring or land cover classification in general. So these 4, they are the 10 meter bands. Now let's think about the 20 meter bands. So B5, red H1, helps us with vegetation stress detection. B6, red H2, again helpful for vegetation monitoring. B7, red H3, again helpful for vegetation monitoring. B8A, again helpful for advanced vegetation analysis. B11, so SWIR1, okay, so we are calling the shortwave infrared 1. We'll have another SWIR as well, and this one helps with moisture content, burned areas detection, distinguishing between the snow and cloud. Snow and cloud in several other channels will be a similar looking, right? So this band provides us with some distinguishability with respect to that as well. Similarly, we have B12 SWIR2, which again helps us with burned area monitoring. We have talked last couple of slides, we have mentioned again burned area monitoring. So at this point, probably it makes sense to also introduce. We have talked previously about a few indices. Let us also introduce this normalized burn ratio, which is calculated as again, like with the NIR and SWIR, you would have automatically guessed hopefully that for Sentinel-2, we would be choosing particular SWIR band or particular NIR band, as we have multiples of them, right? What happens is that with the burnt areas, we see a destruction of the vegetation, causing the NIR value to go down, and it drying out of the surface, drying of the surface, you would have connected this to the moisture, and thus the SWIR value to go high. And thus, what happens is that lower this particular index, lower values indicate generally burn. Again, this is I would say a problem which is quite interesting. It's of course, this index works to some extent, but as I said, the complexity increases of the task. Such indices are less and less effective. I can talk about in the context of stubble burning that happens quite a lot in some north-western states of India, right, like Punjab and all. So it's not that okay, you just use this index and you can really detect them. There are challenges and all, which probably motivates again to actually use deep learning or more sophisticated approaches. Now, let us also quickly go through the 60-meter bands. So 60-meter bands are B1, B9, B10, which is helpful for cloud detection. Again, the Sentinel-2 data, this is available as top of atmosphere reflectance, okay, which we call as often as Sentinel-2 level 1C data, or this is available as surface reflectance, that is level 2A data. For most of our, like, let's say, urban applications or even agricultural applications, most of the time I would say that like if I was asked like, okay, which data to use, we would be using the level 2A. Again, depends on like which particular problem scenario and all, but most of the time, like such applications, we would be preferring level 2A data. Landsat 7 was launched in 1999. So compared to Sentinel-2, which is much recent, Landsat 7 goes back much back in time. However, the mission has been ended already in 2025. Landsat 7, we had enhanced thematic mapper plus ETM plus data, which was the main imaging instrument on board Landsat 7. So these acquired visible, near infrared, shortwave infrared, and thermal data. And the Landsat 7 also included a 15-meter panchromatic band for enhanced spatial details. Landsat 7 had 8 spectral bands spanning visible to thermal wavelengths, 30-meter resolution for multispectral bands, and the 60-meter resolution for the thermal infrared band. So you see, like, the spatial resolution is much coarser when we talk with respect to the Sentinel-2. Landsat 8 was launched in 2013. This acquires image is really like about 16 days compared to Sentinel-2, where we have images like approximately every 5 days. So the Landsat 8 has 2 sensors: operational land imager VLI acquires visible near infrared SWIR data. There is also thermal infrared sensor, which measures land surface temperature. So this is where we see like something additional to the Sentinel-2, right? This provides 11 spectral bands in total, ranging from coastal blue to thermal infrared. So with this, we will end our discussion here, and we will take forward our discussion in the next lecture. Thank you.